Hello everyone and welcome back to the channel. Have you ever wondered how modern vehicles communicate with each other, avoid traffic, improve safety and even connect to the internet in real time? Well, that is possible because of an exciting technology called Vehicular IoT, also known as the Internet of Vehicles. In today's video, we are going to explore the important components of Vehicular IoT and understand how smart transportation systems actually work. By the end of this video, you will clearly understand how connected vehicles make transportation safer, smarter, and more efficient. So if you are interested in IoT, smart cities, autonomous vehicles, or future transportation technologies, this video is perfect for you. Don't forget to like, share, and subscribe to the channel. Now let's get started with the components of Vehicular IoT. Here in this image, you can see the components of Vehicular IoT are: first is the sensors, then you have satellites, wireless connectivity, roadside unit, RSU, cloud computing, and fog computing, and the last is analytics. Here in this image, you can see the Vehicular IoT, which is a smart transportation system where vehicles, sensors, roadside units, satellites, and cloud servers work together by sharing information. And the main goal of this system is to improve the road safety, traffic management, fuel efficiency, and driving comfort. Here you can see the cloud platform. It stores the data, performs analysis, uses artificial intelligence, and provides useful services. And vehicles continuously send information to the cloud and receives updates from it. Now here you can see different modes of communication methods, or you can say different communication methods, where vehicles can communicate with each other through vehicle to vehicle, that is V2V communication. They can also communicate with the roadside units, traffic signals, satellites, and the cloud servers. So this complete communication system, it is called as vehicle to everything, that is V2X communication. Now modern vehicles, these are equipped with many sensors, such as you have cameras, then you have radar, lidar, GPS, speed sensors, temperature sensors, pressure sensors, microphones, and many more. So these sensors collect the information which is very important about the vehicle and its surroundings. Now the working here, it is divided into 5 steps. First is the data collection, where the sensors gather the information such as speed, location, road conditions, and weather. Second is the data transmission, where the information is sent using the technologies like 4G, 5G, Wi-Fi, Bluetooth, and the DSRC. Then next you have data processing, where the cloud and edge servers analyze the collected data. Then you have smart decisions, where the artificial intelligence helps in making quick decisions related to safety, traffic, and routing. And last is the action and feedback, where the alerts and useful information are sent back to vehicles and the drivers. Here you can see the major benefits of the Vehicular IoT, which includes the improved safety, that is accident prevention. Then you have real-time traffic updates. You have fuel efficiency, that is a better fuel consumption. Then comfortable driving experience and the reduced pollution, that is the environmental friendly. So here we can say that Vehicular IoT connects the vehicles, roads, and communication networks to create a smarter, safer, and more efficient transportation system for everyone. Now let's look at the components one by one. First is the sensors. So here the sensors are the eyes and the ears of the Vehicular IoT, or you can say vehicles, because they continuously collect the information from both inside and outside the vehicle. This information helps vehicles make a smart decision, improve safety, and provide better experience or better driving experience. Now here the sensors are divided into 2 main categories: internal sensors and the external sensors. First we'll see what are internal sensors. The internal sensors, these are installed inside the vehicle and they monitor the vehicle's condition and the driver's activities. Now here you can see several common sensors, that is internal sensors and their functions, where first is the GPS sensor, which tracks the vehicle's location. Then you have fuel sensor, Okay, here fuel sensor which monitors the fuel level, temperature sensor, like it checks the engine temperature, accelerometer, it detects speed changes, then sudden braking and accidents, ultrasonic sensor, it helps during parking by detecting nearby obstacles. You have pressure sensor which monitors the tire pressure, and proximity sensor that will detect the nearby objects or close the objects which are very close to the vehicle. Now here you can see a real-time example of the like it is a smart parking assistance. That is when a driver reverses the vehicle. Here you can see he is reversing a vehicle. Ultrasonic sensors will be there which will detect the nearby objects, and the collected distance information is sent to the onboard processor. Now the processor will analyze the data and activates the warning alarms or automatic braking if necessary. Now, this will help the driver avoid collisions. For example, like example of this technology can be seen in the Toyota parking assistance systems and Tesla automatic energy emergency braking systems. Okay, these are the two examples here. Automatic emergency braking in Tesla vehicles. Now, next comes the external sensors, where the external sensors are installed outside the vehicle or along the roads and the highways, and they monitor the traffic conditions, weather conditions, road situations, parking availability, and the vehicle movement. Now, here the image presents several external sensors such as the CCTV cameras for traffic monitoring. Then you have rain sensors for detecting the rainfall, light sensors for detecting the for controlling the street lights. Then you have parking sensors for identifying empty parking spaces, and speed cameras for detecting the overspeeding vehicles. Here you can see a real-time example, that is a traffic violation detection, where a speed camera captures an overspeeding vehicle and records its number plate. Okay, here the camera is there. If the car is coming in like it is overspeeding, then here it will record the number plate, and the image is then processed using the artificial intelligence and the image analytics. After verification, an electronic challan is fine is automatically sent to the vehicle owner, and similar smart traffic systems are widely used in cities such as Bengaluru and Hyderabad. Here here overall you can understand how internal and external sensors work together to collect the valuable data, and this data enables intelligent decision making, improves road safety, reduces accidents, supports traffic management, and helps create smarter transportation system. Now, in short, you can say sensors are the foundations of vehicular IoT, making vehicles and roads safer, smarter, and more efficient. The next component is the satellites. So here satellites provides the GPS connectivity and the location services, and help the vehicles communicate with navigation and the tracking systems, and they play a very major role in making transportation safer, faster, and more efficient. Here you can see the main functions of the satellites, that is they will help in the vehicle tracking for finding the exact location of a vehicle, then navigation for guiding the drivers to their destination using the maps, and you have accident detection for helping emergency services locate accident sites quickly. You have traffic monitoring for observing traffic conditions and congestion. Then you have route optimization, where it will suggest the shortest and the fastest routes. So here you can see that the satellite is communicating with the vehicles on the road, and the satellite continuously exchanges the location information with vehicles and sends the data to control centers. Now here you can see a real-time example, that is the ambulance tracking system. So the first step here is the location data collection, that is the ambulance is equipped with a GPS device here, and the GPS sends the ambulance location to the satellites. Then the satellites will determine the exact position of the ambulance and forward the information. Then in the second step, it is the real-time monitoring, where the location information is received by a control center. Operators will monitor the ambulance on a digital map in real time, and this will allow authorities to know exactly where the ambulance is at every moment. Then you have green corridor creation, that is here based on the ambulance location, the traffic management system automatically adjusts the traffic signals. Okay, that is the red signals on the ambulance route are changed to green. Then this creates a green corridor, okay, allowing the ambulance to move without delays caused by the traffic. Then fourth is the faster hospital arrival. Now because the traffic signals are coordinated and the route is optimized, the ambulance reaches the hospital much faster. So this can save valuable time during medical emergencies and may even help save lives. So here like you can see that uh, emergency like uh, such type of emergency vehicle tracking systems are used in the India Smart City projects here. You can see here. And these projects use modern technologies such as GPS satellites, then communication networks and traffic management systems to improve public services and road safety. Then next component is the wireless connectivity, where wireless communication allows the vehicles and the devices to exchange the information without using the cables, and this will help the vehicles communicate quickly and efficiently, making transportation safer and smarter. Now here you can see the common technologies which are used in the vehicular IoT, that is Wi-Fi, which enables the short range internet communication. You have Bluetooth, which connects nearby devices wirelessly. Then GSM, 4G, 5G, which will provide mobile network communication for faster data transfer. Then you have Zigbee, which supports low power wireless communication. Then next is the DSRC, that is the dedicated short range communication, which is specially designed for communication between the vehicles and the road infrastructure. And here you can also see three wireless connectivity, that is the three important communication types. First is the vehicle to vehicle, which exchange the information with where the vehicles will exchange the information with each other. Then you have vehicle to infrastructure, that is V2I, where the vehicles communicate with traffic lights, road sensors and the roadside units. Then you have vehicle to cloud, V2C, where the vehicles send and receive the data from cloud servers. Now here you can see a real-time example of collision warning system, where in the first step sudden braking is there, where a vehicle on the road suddenly applies the brakes because of an obstacle or the emergency situation. Then second step is the wireless alert transmission, where the vehicle immediately sends a warning message through the wireless communication technologies such as the DSRC or 5G to nearby devices or the vehicles. Then third is the alert reception, where the following vehicles receive the warning alert in the real time. Okay, here these vehicles will receive the alerts in the real time, and the drivers are informed about the danger ahead before they can see it directly. Next, fourth step is the accident prevention, where the drivers will reduce the speed and maintain a safe distance or apply the brakes, and this will help prevent collisions and improve the road safety. So here you can see the working of the system, where the vehicles will detect an event. Data is transmitted through the wireless network, roadside units or communication network will process the information, and the data is shared with the vehicles and the cloud servers. So finally the image here this will mentioning that connected car systems using wireless connectivity are available, okay, here in vehicles manufactured by BMW and Mercedes-Benz. So overall we can say that wireless connectivity enables the real-time communication, faster decision making and safer transportation by connecting vehicles, infrastructure and the cloud services. Fourth component is the roadside unit, which is a fixed communication device installed near the roadways, highways, intersections, then and the traffic signals, and it acts as a bridge between the vehicles, local processing systems and the cloud servers. So here you can see that the vehicles, these are communicating with an RSU through the wireless communication, and the RSU will collect the information from the nearby vehicles, and it will manage it will help manage traffic in real time. Now these what these RSUs do, or what are the functions of the RSUs. First is the traffic monitoring, where it continuously observe the vehicle movement on roads and collect the information such as the vehicle speed, then traffic density and the traffic flow, and this will help authorities to understand current road conditions. Then you have the data processing, where these can process data locally by using the fog computing. Instead of sending all data to the distant cloud servers, important information is analyzed near the source, and this will reduce the delay and allow faster decision making. Then you have emergency alerts, where these RSUs will send warning messages to nearby vehicles about the accidents, roadblocks, dangerous weather conditions or traffic congestions, and the drivers will receive alerts quickly and can take necessary action. Then you have communication bridge, where this RSU will act as a communication bridge between the vehicles and the cloud servers, and they will receive the information from vehicles, then they will process it, and next forward the important data to the cloud systems for further analysis and the storage. Now here you can see a real-time example, that is a smart traffic signal, where the first step is the RSU will detect the heavy traffic at a road junction here, okay, and it will collect the information from the vehicles and the traffic sensors. Second is the fog processor will a processor connected to the RSU. It will analyze the traffic density and determines which roads are congested. Then you have step 3, that is based on the analysis, the traffic signal timing changes automatically, and roads with more vehicles receive a longer green signal. Then you have congestion, that is a traffic congestion, where it is reduced because vehicles will move more efficiently through the junction. Now some real-time examples are adaptive traffic management system, which is used in Singapore and Dubai, and these cities use smart transportation technologies to monitor traffic and improve the road efficiency. Okay, so the RSUs will collect, process and share the information in real time, and these will enable smart and efficient transportation system. Next you have cloud and fog computing, where the vehicles will generate a huge amount of data every second. So every second through the sensors, cameras and the GPS devices, and also the communication systems, and this data must be processed quickly and efficiently in order to support safe and intelligent transportation. Now the data processing, it is divided into 2 methods, that is the fog computing and the cloud computing. First we will see what is fog computing. So here fog computing, it will process the data close to the vehicle or roadside unit, and instead of sending all the information to a distant cloud server, the data is analyzed near the source. Now some of the features of this fog computing are faster response, then low communication delay, and it is suitable for real-time applications and also quick decision making. Here you can see that vehicle is communicating with the RSU and the nearby fog node, and the fog node immediately processes the important information. Now one real-time example for this is the road accident alert. That is a road accident occurs and the nearby RSU will receive the accident information. Then the fog node quickly processes the accident data without waiting for a cloud server. After that, the warning will be sent, that is the warning alerts will be sent to the nearby vehicles within a few seconds, and the drivers in last step, the drivers will receive the alerts and choose alternate routes, helping them avoid traffic congestion and improving safety. Now because processing happens nearby, fog computing provides very faster responses. Okay. Now second is the cloud computing, where it processes large amount of data collected from many vehicles over a long period, and the cloud servers are having powerful computing resources and large storage capacity. Now the features of cloud computing are large data storage, high computational power, long-term analytics, and historical data analysis. And we'll see a real-time example for traffic analysis, where the cloud server will perform the following task. That is, first it will collect the traffic data from the vehicles for several months. Then it will analyze the traffic pattern using the advanced analytics. Then in the third step, it predicts the peak hour traffic congestion and identifies the busy routes. And in the last step, it will suggest optimal traffic management strategies to improve traffic flow and it will reduce the congestion. So here we can say that fog and cloud computing work together in vehicular IoT, and fog computing provides instant response near the vehicle, while the cloud computing provides deep insights and long-term intelligence. So next here you can see the difference between the fog and the cloud computing. Here both are used to process vehicle data, but they work in different ways and serve different purposes. So here we can see first feature we have taken to compare these to find the difference is the processing location. In fog computing, data is processed near the vehicle, usually through a roadside unit, okay, here, or a nearby fog node. Now, since processing happens close to the source, responses are very quick. Whereas in cloud computing, data is sent to the remote data centers located far from the vehicle, and the cloud stores and analyzes large amount of information. Second feature is the speed. The fog computing provides very fast processing because the data does not need to travel long distances, and cloud computing offers moderate speed because data must first be transmitted to remote servers before processing. Then you have the third feature, which is the delay. Where the fog computing has low latency, meaning there is a very little delay between the data collection and the action, whereas the cloud computing has higher latency because information travels through the internet to distant cloud servers and back. Then coming to the last feature, that is the usage. The fog computing is mainly used in real-time decisions such as accident warnings, emergency alerts, and the traffic signal control. And cloud computing is used for large-scale analysis, long-term data storage, traffic prediction, and generating the reports. So this fog computing, it works, that is, here you can see the working. Where a vehicle is sending data to the RSU, the RSU will forward the information to a nearby fog node, which will process the data locally. Then immediate alerts or actions are then provided to the drivers, and this allows quick responses during the emergencies. Then here you can see the working of cloud computing, where the vehicle data is being sent to the internet to a cloud data center. Then the cloud store huge amounts of information, okay, analyzes the traffic patterns and generates the insights for future planning and traffic management. So the fog computing is best for fast real-time actions, while the cloud computing is best for storage, analysis, and long-term planning. So together they will help make transportation systems smarter, safer, and more efficient. Then comes the sixth component, that is the analytics, where it is a process of converting the raw data collected from the vehicles, sensors, GPS devices, and communication networks into the useful information. So this information helps to improve transportation systems and support better decision making. So here you can see that the raw data, it is it is collected from the vehicles, is processed and analyzed to generate the meaningful insights. So you can see three important technologies here which are used in the analytics purpose. That is, first is the artificial intelligence, which helps system make smart decision automatically. Then you have machine learning, which learns from past data and improves the prediction over time. You have big data analytics, which will analyze the very large amount of data from many vehicles and devices, and these three technologies help predict and optimize the transportation systems. Then here you can see the applications of analytics. The first is the traffic prediction. where the analytics studies traffic data and predicts congestion before it occurs, and this helps drivers avoid busy roads. Then you have accident prediction. That is, by analyzing accident records and traffic conditions, analytics can identify risky locations where accidents are more likely to happen. Then you have fuel optimization, where this analytics helps drivers choose efficient routes and driving patterns, reducing fuel consumption and saving the money. Then you have driver behavior analysis, which will analyze, where the system will analyze driving habits such as speeding, harsh braking, and sudden acceleration to improve road safety. And the last is the smart navigation, where the analytics recommends or suggest best and fastest routes based on current traffic conditions. Here you can see a real-time example, that is the Google Maps traffic prediction, where in the first step, millions of smart phones and vehicles send the GPS location data continuously, and in the second step, analytics engines process both real-time data and the historical traffic data using the AI, ML, and the big data technologies. Then here you have step 3, where the system predicts the traffic congestion, road delays, and travel times. And the fourth step is users will receive the fastest route suggestions on their navigation apps, helping them reach their destinations quickly. So here you can see the working of the analytics in the vehicular IoT, where data is first collected, then transmitted through the communication networks and processed using the AI, ML, and big data analytics tools, then and finally converted to into useful insights and decisions. Then you will get the optimized transportation. So here you can see that this analytics, it is a powerful component of the vehicular IoT, and it transforms large amount of vehicle and traffic data into valuable information by predicting traffic and improving navigation, reducing fuel usage, enhancing the road safety. Analytics helps create smarter, safer, and more efficient transportation systems. So this was about the components of vehicular IoT. Thank you.